Okay, so then as a quick review for those of us who are interpreting oral pieces that or oral interp, is that how you refer to that? Yeah, oral interpretation. So for those two of you who are gone, we had done similar examples to this yesterday. So as we look at this then, remember we just said if there's nothing written after these numbers, it's just telling you where either the double bond or that hydroxy group is located. And once you're done, you can just leave it on the desk. It'll be fine. Just leave it, or you got a question. Okay. On that desk, yep. Okay, thank you. Okay, so now some other examples that we had done was, now hopefully I can remember this from yesterday. Sometimes what happens is there's more than just one OH group on here. So with that, I think what we had done is maybe something like this. Okay, well then you're still going to have a lot of the same naming, but now how is this going to be just a little bit different? Okay, so we're going to have to put 1, comma 3. Then we've got diol. Okay, then you just put this over here and it's diol. So again, you can reverse engineer this and say, okay, this is telling us there's an alcohol. Okay, with the OL, the di is saying that there's 2 OH groups. Here's your 5-carbon parent chain, and then again, there's nothing written after these, so this is telling you where those OH groups are located, first and third. So there they are located. Now, what happens is, well, you could very well have something like this. I'm thinking this is something similar that we wrote down. And if we take this guy and this guy out and do that, now I've totally changed a lot of things in that compound. Okay, the parent chain is still the same, so we're going to erase all of this because we're going to go ahead and start over. So with this, what we see here is we've got this organic family. Now this is still part of the parent chain, but we need to denote these as alcohols. But we haven't changed the number of carbons in here in the parent chain, so we can still do this. Okay. Okay, so that's saying that we need EN. All right. So what happens with this is, well, what happens when you have OH groups on a double bonded carbon with a alkane derivative or alkyl derivative? Okay. Well, what we would have to do is we can't do this. Or no. Sorry, I didn't do that. Right. We can't do this. 1, comma 3 dash 1 dash pentene. Because notice with that same type of logic, if there's nothing written after here, you're denoting where those double bonds are and where those hydroxy groups are, but we can't. You don't know which number's which. I mean, with practical experience you could, but to communicate that information logically, you wouldn't be able to use this. Well, in this case it does, because you have that guy on there. Yep. And it's, to me, the only time you'd ever do that is if these 3 things are not on there. Then it would be understood that it's just after the first carbon. So notice that we can't leave it like this. But what we can do, okay, is we can take these 2 numbers right here. We're going to move them over here, like we did in that prior example where we said diol. But instead, we're just going to number where they're located, which is still pentene dash 1 comma 3 dash diol. Okay, so that way you're able to separate where these OH groups are located and where that double bond is. So when you put it way over here, now you've illustrated where they're you've correctly named them. Now the last thing you need to do, what's left, yeah, so then you just have 2-methyl. And from prior examples, notice that there's something written after that 2, which is not correct. It should be 3. That something was written after that number, so that's telling you where your methyl group is. So anytime, like we said yesterday, I think it's essentially true, the idea that it's always going to be easier to actually see this information and then write out what that compound is. But when you actually have to name this, it gets to be a little more difficult, especially at this level. But you can always reverse engineer that, going from right to left, saying, okay, OL, we know that that is an alcohol. So this is saying there's 2 of them. This is saying where they're at, 1 and 3. This is saying that, okay, it's an alkene. Here's your parent chain. And then this is saying where that double bond is located. This is saying there's a methyl group on the 3rd carbon. Okay, so you can always reverse engineer that and then go back and see, once you got this wrote out, and look back and say, yes, that would be right. Okay, well, I think for all practical purposes, we'll just leave it as that, as a review, and then we will pick up with this other information that we see here, this tertiary alcohol chemical reactivity, because what I want to do is be able to talk about this intermolecular dehydration, because it says we briefly talked about that yesterday, and we'll get to the oxidations then as well. Okay, so we'll pick up with this next time.